We're going to go ahead and take a look at number 77 from section 2.1, which deals with the rectangular coordinate system. So number 77 is asking you to calculate the distance between 2 points, and these 2 points they've labeled as P and Q. Point P in this case is going to have the value pi for its x value and -2 for its y, and point Q will have a x value of pi and a y value of 5. So one of the first things that we need to do in order to actually calculate the distance, we need to recall that the distance formula is as follows. The distance is equal to the square root of x1 minus x2 squared plus y sub 1 minus y sub 2 squared. If that seems like it sounds a little bit foreign to you, a different way of kind of saying it would be that the distance is equal to the square root of the change in x, or the difference between your x values, squared, plus the change in y, or the difference between the y values, squared. If you kind of look at it in terms of, if you actually use a visual like a coordinate plane, you can plot both of the points and kind of see if you can measure the distance by visually looking at it, by looking at how far the line has risen between the 2 points and how far apart the 2 points are if you look at the horizontal axis. So in this case, we'll go ahead and we'll start plugging values in. One of the first things that you want to do is note which coordinate point houses your x1 and y1 value and which one houses your x2 and y2 value. So I've arbitrarily picked point P to be my first point, so that's why they have the subscripts of 1, and point Q has the subscripts of 2, because that's my second point. If you flipped your choices, that's completely fine. That will still give you the same solution. Okay, in this case, you have a little bit of wiggle room in terms of which you choose to be your first point and which you choose to be your second point. So if we go ahead and plug this in, we know that x1 will be pi minus x2, which is also pi, squared, plus y1, which is -2, whoops, minus y2, which is 5. I don't know why I put a comma there. I guess I really wanted, I was in coordinate point mode and not subtraction mode. So when we go ahead and clean this up, we want to use our basic order of operations to kind of bring us back to something that's a little bit more concise and a little bit more familiar in order to evaluate and simplify. So pi minus pi, well, the good news is that's 0. And -2 minus 5, that's going to give us -7. Okay, so if we were to go ahead and clean this up further, 0 squared is 0. And -7 squared, and again, notice that that -7 is housed in parentheses, and the square is on the outside of those parentheses. That's going to give us a positive 49. Well, this is a really easy addition, right? 0 plus 49 is 49. And the square root of 49 is going to give us 7. I'm not going to concern myself with the plus or minus in this case, because we know that distance can never be a negative value. It doesn't make sense. We can either stand still or we can only move forward. So there's a positive outlook on life using mathematics, isn't it? So here is your solution. So we have a distance of 7 units between these 2 points. And this point, this distance problem is actually kind of nice, and we can easily see it by demonstrating it visually. Because if you notice, both of the points that you are given are have the same value. Both of them have an x value of pi. So if I were to plot this, and I'll do it in pink maybe, we're just going to eyeball it. So 3.14 is the approximation that we use for pi, so it's it's somewhere between the 3 and the 4 tick mark on the x-axis. And then -2. So let's say it's about here. So here's point P. And then point Q is about here. So if we were to connect those points, it gives us a vertical line. So it's easy to kind of count and see, okay, how many units are there between here? Notice that there is no horizontal change. It's all on one vertical lines because there is no slope here. So I would go 1, 2, 3, 4, 5, 6, 7 units. So you could visually kind of justify your algebraic work. Okay, there you go.